5.2 is probability and odds. So what we're doing is interpreting odds and then relating them to probability of something happening or not happening. So there's two main things that we look at here. We look at odds in favor and odds against. So odds in favor is just the ratio of the probability that something happens to the probability that it does not happen. Or it can be written as a ratio of the number of favorable outcomes to the number of unfavorable outcomes. So that's odds in favor. So you always put the favorable first. Odds against then is the ratio of probability that an event will not occur to the event probability that the event will occur. Or the ratio of number of unfavorable outcomes to favorable outcomes. So odds in favor puts the favorable first in the ratio. Odds against puts the unfavorable first. So just a basic look at ratios, or a refresher. An oil and vinegar salad dressing is made using 2 parts of oil to 1 part vinegar. So the ratio of oil to vinegar is 2 to 1. What fraction of the dressing is oil? So if it's being mixed in a bowl, you have 2 parts oil and your 1 part vinegar. So altogether then, there are 3 parts that make up your salad dressing. So if oil is 2 parts of this, then it would be 2/3 of the dressing would be made up of oil. So then that would mean that 1/3 would be made up of vinegar. So taking that a little bit further and using it with probability. Remember, probability of an event occurring is between 0 and 1. So it says, suppose that at the beginning of a regular CFL season, the Saskatchewan Roughriders are given a 25% chance of winning the Grey Cup. The event in this situation is that the Riders win the Grey Cup. So B part says, express the probability that this event will occur as a fraction. So you're given 25% chance, so that's 25 out of 100. That's 25%. So if we reduce that, because in order for it to be in probability, it has to be between 0 and 1, would be 1 out of 4. The complement of this event, so if you remember back from last chapter, the complement of an event is the opposite, or the not happening. So the complement of this event would be that the Rough Riders not winning the Grey Cup. So if we take a look at that, in terms of expressing it in probability, it would look like this. So probability Rough Riders don't win the Grey Cup. We want to express this as a fraction when they're done. So probability has to be between 1 and 0 and 1. So in order to figure this out, probability of it not happening is we take the not happening, or the complement, is equal to 1 minus the probability that it happened. So 1 minus the probability that it happened was 25 over 100. So that's 75 over 100, which reduces to 3/4. So it's a 75% chance of them not winning, or if you reduce that as a fraction, it would be a 3/4. So odds then, write the odds in favor of the Rough Riders winning. So remember from the definition, odds in favor are favorable outcomes, probability of favorable outcomes compared to probability of not favorable. And you can write it as a fraction, or you can write it as a ratio. So probability of them winning over probability of them not winning. So probability of them winning was 25 out of 100. Probability of them not winning was 75 out of 100. And you could have used the reduced. You could have used the 1/4 and the 3/4. They'll still give you the same answer. So if we're dividing with fractions, we multiply by the reciprocal, so we'd have 25 over 100 divided by, or times 100 over 75, so our 100 was canceled and we're left with 25 over 75, which is 1/3. Or as a ratio, you'd have a 1 to 3 chance, or odds in favor of them winning. So then F says, write the odds against the Rough Riders winning. So odds against is probability of it not happening compared to probability of it happening. So if you look in the little box here, you have probability of A complement over probability of A, or probability of A complement with the ratio to probability of A. So probability of not win over probability of win. Well, that was 75 over 100 was the probability of the win, and 25 out of 100 of them winning. So this is 75 over 25, which reduces to 3 over 1. So a 3 in 1 odds against them winning. And if you notice, odds in favor and odds against, if you compare the two, all you've done is flipped that fraction or flipped that reciprocal. So when you're dealing with the same events, just the complement of them, then when you're looking at the odds, you're just flipping one to the other. So example 1 says, research shows that the probability of an expectant mother selected at random having twins is 1 out of 32. So it says, what are the odds in favor of an expectant mother having twins? So probability of them having twins, according to this research, is 1 out of 32. So the ratio of twins to all birth combinations is 1 to 32. Probability of not twins, then, is that 1 minus probability of that favorable outcome, or probability of twins, so 1 minus 1 over 32, which would be 31 over 32. So the ratio of birth combinations that are not twins to all birth combinations is 31 to 32. So the next part said, what are the odds in favor of having twins? So odds in favor are the probability of having twins compared to probability of not having twins. So probability of having twins was that 1 over 32. Probability of not having twins was 31 over 32. So if we multiply by our reciprocal, we're left with 1 over 31. So as a ratio, this would be 1 to 31 odds in favor of having twins. Odds against then, and if you remember from what I said before, the only difference between odds in favor and odds against is just flipping your ratio. So odds against an expectant mother having twins would be 31 to 1. So you have more of a chance of not having twins than you do of having twins. So making decisions based on odds and probability. It says a hockey game has ended in a 5-minute overtime period, after a 5-minute overtime period. So the winner will be decided by a shootout. The coach must decide whether Ellen or Brittany should go first in the shootout. The coach would prefer to use her best scorer first, so she will base her decision on the players' shootout records. Who should go first? So in order to do this, we have to take a look at the probability of them scoring. So there's two methods we could use. So method 1 is if we take a look at Ellen and we calculate her probability of scoring. So she's made 13 attempts and she's scored 8. So that would mean she would have 8 favorable out of all possible. So it would be 8 over 13, which if you calculate that is 0.615 approximately. So she has 61.5% chance of scoring. For Brittany, probability of her scoring, so probability of her scoring is a number favorable, so 10 out of a possible 17. So 10 divided by 17 is 0.588, which is 58.8%. So that's one method of doing it. The second method of doing it, so this is just calculating their probability. The second way is to look at odds in favor of them scoring. So in order to do that, you have to take a look at the complement. So we have goals scored to goals not scored. So if Ellen had 8 goals, attempted 13, that means she didn't score 5 times. Brittany had 17 attempts, 10 scored, so that means she didn't score 7 times. So odds in favor then, if we looked at it that way, so odds in favor means we take a look at the odds in favor of it happening compared to the odds in favor of it not happening. So in this case, for Brittany, she would have a 10 to 7 ratio for Ellen. She would have a 8 to 5 ratio. So when you're looking at this, what you want to do to compare them is, one of the ways to do it is to get your, I'm just going to change my pen color, the unfavorable, so that they have the same, like a common denominator, if you want to think of it that way, in order to compare them. So between 7 and 5, my common denominator would be 35, so that would mean I multiply each one of these by 5, and in this one I would multiply by 7. So that would change my odds in favor to 50 to 35 for Brittany, and 40 to 35 for Ellen. Nope, sorry, I didn't multiply. 8 times 7 isn't 40. 8 times 7 is 56. So if you look at the 50 to 35 and the 56 to 35, this is a more favorable outcome, just as this percentage is more favorable. So this is probability. And this is odds in favor. So no matter which way you do it, Ellen's probability and odds in favor are better. So she should shoot first. Okay, so you can do it either way. You can take a look at the probability of it. So probability is number of favorable outcomes over number of all trials, and odds is comparing number of favorable outcomes to number of unfavorable outcomes, and then finding a common denominator. So depending on the question, it's not going to matter which way you do it unless it says find the probability of it. If it says probability, then you use method 1. If it asks you to find the odds, then you have to do method 2. So your assignment is there at the bottom. There's some more examples in the textbook too. If you want to look at those, feel free.